Okay, welcome to the week 2 statistics webinar. So I do want to remind everyone that that is being recorded, but if you put in the chat box, it is doesn't have any, no one sees the chat box. And but if you feel comfortable to ask any questions, they'll hear you, but it will be recorded and posted on YouTube. But I'll be happy to answer any questions throughout the this webinar. And let me talk about the plan for today in terms of what the webinar is about. So as always, I'd like to start out with any questions and you might have. And then if you come up with questions mid-through, please ask them. So that's kind of what this is about. Then we're going to get into probability. So a big thing today is chapter 3, which is probability. I want to give you a little warning. Last week, we did 2 chapters. This week, we do 1 chapter. Next week, we do 2 chapters. Which do you think is the harder of the 3 weeks?
This week?
This week, yeah. There's only 1 chapter expected to be a hard chapter, because if I put 2, that means that they're not that hard. You can put them together pretty easily. But this could be somewhat hard, especially for those who are not math lovers, because this is one of the heavier math days of the whole class. Nothing too intense in terms of math, but a lot of math rules, and we're going to be getting that into the definition of probability. Okay, so I'll define probability, and then we'll spend a lot of time using it. Okay, and in fact, this whole course, we are going to be using probability. That's really what this is, in very deep ways. Sometimes it's so difficult that you just trust me that I wrote my calculator correctly and it just does all the calculations for you. But really, everything we do does probability. But most of what we do is too hard for you to do it by hand or to even be expected to know how to do without a calculator. Okay, so one of the examples I'm going to do, because maybe I'm going to be worth hundreds and hundreds of millions of dollars. You know why? Because I bought a lottery ticket. So here's my lottery ticket. And the question is, how likely is it that I'm going to win the lottery? Okay, which, by the way, will get picked tomorrow. So that'll be a big day for me if I win, but we'll see what is the probability of me winning the lottery tomorrow, since I bought my ticket today. And then this looks really easy. And so we're going to be looking at the word and in probability. And that has a very special meaning with a math equation. So we'll get into that. Then we're going to get into the word or. And that also is a special meaning in probability with a math equation. Then we'll get into given. Again, special meaning with the math equation. So there's going to be a lot of math equations in this particular chapter. So be ready for that. Then we're going to get into what it means for 2 events to be mutually exclusive. That's actually not that hard, but is important. It comes up a lot. And then the last piece of probability, we'll say, what does it mean for 2 events to be independent? Okay, what does it mean for 2 events to be independent? And again, that's going to be really important. That one is going to be a more complicated math equation, but we'll be able to live with it. And it turns out there's 3 different equations, so we'll be able to handle it, hopefully. So that is the plan. And I want to remind you all, if you have any questions, please ask your questions. This is a great time. You can pop it in the chat box. And by the way, we're going to finish off with talking about Project One. So I'm going to get you all set up. Hopefully last week you all got partners, because that was what I asked you in the webinar last week, was find partners. And now you can start working on it after today, because we'll go fully over, most of the details of what you are expected to do for Project One. So are there any questions about anything in this class or anything else? This is a great time to ask. a second or two, but I'd love to answer some questions. Questions? Okay, if there aren't any questions, I'm going to move on. But again, feel free to, ask a question whenever you have one. And it could be what I'm talking about, or it could be something from before, but you forgot to ask now. And that's fine. I'll be happy to answer. And I also answer questions at the end. After I stop the recording, just in case you're worried about like people knowing who you are or something. But honestly, only you guys look at these videos pretty mostly, not always. I do want to mention that we did have assignments due last week. I have graded some of them. I'm human, so I can't just instantly grade. But I have done some grading. Make sure that you go and take a look at my comments that I put in the grading, and also look at your grading, your grade. And if you have any questions, you can ask. But again, I'll be grading throughout the quarter. I still have a little bit left to grade from this week's stuff because I can't just do it all at once. We had 60 students in the class, so it takes in the two sections. It takes a while for me to get through all of it. But hopefully, within the next day or two, I'll have it done. I'm not a procrastinator. I tend not to wait till the end to grade. Okay, let's talk about probability. Again, probability it's a major component of this entire course. So we need what does it mean to be a probability? And it turns out the definition of probability is going to be a fraction. And I like to look at things. So let me grab one. Something that hopefully everyone knows. Y'all know what that is? So hopefully you all know there's a quarter. And I can take the quarter and I can flip it, look at it, and say, is it a head or is it a tail? Okay, so hopefully you've seen that before, probably, right? So now the way we write that is we use the letter P, capital P, for probability. So again, mathematicians tend to be a bit boring. So if it's about probability, what letter should we use? P. So it's usually what you expect. So P for probability, and then you put a parenthesis, and then you write down what you want the probability of. Okay, and often you do kind of shorthand. You don't usually write full sentences or anything, but one word is enough if you understood what we're doing, and that's flipping a coin. And we want to say probability of heads is the way you read this. Then you close the parenthesis, and then you write equals. And then a probability is always a fraction. Okay, you could turn the fraction into a decimal, but it turns out you think of a probability as a fraction, and the way you do it is you have the numerator of that fraction is the number of ways this inside the parenthesis can happen. So if you look at these two, look at the coin, how many of these sides are heads? Is a very easy answer. I hope you can all tell me. Put in the chat box if you want. Yeah, there's one head on this coin. So I'm going to put a 1 here. Okay, so the numerator is the number of ways what's in these parentheses can happen. The denominator is going to be the number of ways things can happen. So how many different sides are there on this coin? Yeah, so there's 2 sides on the coin. So the denominator is 2. Okay, so we can say the probability of flipping a coin and getting a heads is 1/2. Okay, my guess is you probably all knew that ahead of time before today. I like to start easy, and then we will move and get more and more difficult. Probabilities are not always as easy as, or almost never as easy as this example, but it's our first example. So any questions on how I computed and how I wrote the terminology or the notation for this probability example of getting heads on a coin flip? Any questions? Okay. One of the things that if you're, I'm not sure where y'all from, maybe you can put in the chat box where you are right now. What city? So where are you? Okay, so I'm seeing that's how this class is like that. So far, no two people are in the same city. We got, yeah, so no two people in the exact same city, but one of the things is where I am and where this college is in Lake Tahoe. And in fact, it's just about 3 miles from this college is the state line in Nevada. On the other side is gambling. So one of the things that you will see in the casinos are these guys, cards. Okay. What I will not, tell you is you have to memorize everything about cards, but these are cards. And if you don't know, that's okay what I'm asking you, because if you're doing an assignment, you can always look it up to find out things like, what are cards? Because not everyone knows, is familiar with cards, but I'm going to go over it a bit. So what I want to say is, what is the probability? I'm going to pick a card, just like that. And what is the probability that this card is a spade? So the idea is the notation is use capital P. Then you go parenthesis. And then inside, you put what you want the probability of, in this case, being a spade. And then you close the parenthesis. And then you write equals. So the notation is always going to be similar. And then we say, how many spades are there in a deck? And if you don't know, this is a spade. This is a club. There's a heart. And there's a diamond. And the question is, if I pick a card, what is the probability that this card is a spade? So who knows how many spades there are in a deck of cards? See if you can put in the chat box. Okay. Yeah, I'm seeing a couple of things. There are 13 spades. So one of you got it right. There's an ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. There were 13 of those, by the way. So there are 13 spades in a deck. Okay. By the way, there are 4 suits in a deck. Each suit has 13. So 13 will be the numerator. Now, who knows how many cards there are in there's a regular deck of cards. In fact, it's a little sad if you're from here. It's Lakeside Inn, which closed down because of COVID, and it's never coming back. Yeah. So those who know, it's a bit sad. They gave me these cards so I can use them in my class. So how many cards are there in the deck? Yeah, there's 52 cards. Okay, so there's the probability of getting a spade is 13 over 52. Okay, just a note, you should understand this, and that is there are different ways of writing this. One is 13 over 52. Another will be, you can reduce the fraction and write it as 1 over 4 if you love math. And 1 over 4 is simpler in terms of looking at it, but it doesn't tell the story as well as 13 over 52. Because 13 over 52, you can really see number of spades and number of cards. 1 over 4, that 1 and the 4 don't tell you that much. So it depends what you're looking for. And when you're doing an assignment on the computer, read the instructions. Some will say, write it as a fraction. Some will say, write it as a reduced fraction. If it was a reduced fraction, you'd have to write 1/4. Some will say, write it as a decimal. And you can always put it in a calculator, or you can do what I do, which is weird, and do it in my head. And I get 0.25. So always read the instructions when you're doing the assignments, and make sure you look to see what it's asking for and you do what it asks for. One thing about computers is they will, if you don't do what it asks for, they just zap you. Okay, it's very different than what I would do if I were grading by hand. So make sure you read what it asks for. Any questions on these two very simple examples? All right, so now we can go to the formal definition of probability. And that is a probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. So sometimes you write P parenthesis A and the parenthesis equal the number in A divided by the number in the entire set. And we've done 2 examples. This is one of those, right? I think it's easier to see examples and then see the definition than vice versa. Are there any questions about this definition? Any questions?
No. She's never looked good.
Okay, so if there's no questions, we can do another example. And now what we're going to do is we're going to get them more and more complicated. So I'm going to mix the deck. And I'm going to pick a card, not show it to you. And then I'm going to pick another card and not show it to you. And I'm looking at my 2 cards. And the first thing I want to do, something that's pretty easy, is what is the probability that the first card that I picked is a king?
This meeting is being recorded.
I know this is gonna be.
So what is the probability that the first is a king? Okay, I'm hearing you talk. I'm not hearing questions, so I am going to put you on mute. But feel free to unmute yourself if you want to talk. Okay, so if we want the probability the first card is a king, you say, how many kings are there? Well, there's a king of hearts, king of clubs, king of diamonds, king of spades. There's 4 of them. And how many cards are there? There are 52. Good. So a lot of you said 4 or 50. There's 4 out of 52. Okay. We want to find out the probability that not just the first is a king, but we want both to be a king. Okay, that's much less likely. Okay, so to do that, to find the probability that both are kings, we're going to have to do some work. And what we're going to do, the first thing is I'm going to kind of rewrite it and say, what is the probability the second card is a king if we know the first is a king? I'm going to start with that little piece right there, is finding that probability that the second is a king given the first is a king. Okay. So the first thing I'm going to do is put it in notation, P for probability. And then we open a parenthesis. And then we put the second is a king. I'm going to write that as K2. And see this little vertical line segment right here? That, the way you read that is given. So it's a probability the second is a king given, and then K1, the first is a king, and then you end the parentheses. Any questions on the notation of this? Any questions? Okay, and I saw someone actually put their thoughts in it, and that was great. But let me explain how you arrived at that. And that is, if I'm given, so I'm going to pick 2 cards, and guess what? Here's the first card I just picked. And that is a king. And I'm going to take that card, I'm going to put it to the side. And now I'm going to pick a second card. So the idea is now we're going to look at the fraction again. How many kings are there left that this card could be? The second card could be. How many kings are there? There's 3. So that means the numerator for this example is going to be 3. How many cards could it be? How many cards are, yeah, there's 51 because we know it's not the king of spades because that's the one we just saw. There's 51 cards left because we saw one of them, the king of spades, and it's not that one. There's 51 others. That's going to be 3 over 51. Any questions on that example so far? All right, so next, to be able to do this, we're going to need what's called the multiplication principle. And here's what it says. It says the probability of A and B. So and means both of them must happen. And that is equal to the probability that the first happens, P of A, times the probability that the second happens given the first happens, or P of B, little line segment, or given A. Okay? Any questions on this big principle? All right, so now we're ready. So we can say that the probability that we have 2 kings is going to be the probability that first is a king, that's probability of A, times the probability the second is a king, given the first is a king. Any questions on that? We've already calculated that. The probability that the first was a king was 4 over 52. The probability the second was a king, given the first, was 3 over 51. And then I'm not going to waste your time, but I put that into a calculator, and I got 0.0045. Notice very small chance, right? Less than 5 in 1,000 chances. So let me ask you, are there any questions on this example that talks about the given and the and? Any questions on that? I want to give you a big heads up warning, and that is I like to think of probability a lot like kickboxing. Kickboxing is really easy to watch. Okay, you could just sit there and turn on your TV if there's some big, television thing on it. You just sit there on your couch and watch the thing happen. But if you have to do it yourself, do you think it's easy? Kickboxing? What do you think? No, not at all. Not at all. It's painful. Okay. And by the way, yeah, it is tough. It is tough. And by the way, I was a martial arts instructor, kickboxed a lot. So I could tell you from experience, it's a lot easier to watch other people kickbox than to do it yourself. So I used to. Okay, so now let's get more complicated and actually something that is worthwhile if you live in Tahoe, but you got to get really good at probability. So suppose you pick, instead of 1 card, I'm going to pick 5 cards. There's my 5 cards. And let's say we're playing poker. And I'm not going to get into the details of all the rules of poker. I'm just going to talk about this one example. So the question is, what is the probability that what I'm holding right here is a royal flush? Now, if you don't know what a royal flush means, that means you have a king, queen, jack, ace, king, queen, jack, and 10, all of the same suit. Okay? So that's what a royal flush is. I want to find out the probability of a royal flush. Okay, so I'm going to write that as P, parenthesis, royal flush, and the parenthesis equals. Now my numerator is how many royal flushes are there? So let's think about it. Yeah, there's 4. because you can have ace, king, queen, jack, 10 of hearts, ace, king, queen, jack, 10 of spades, ace, king, queen, jack, 10 of diamonds, ace, king, queen, jack, 10 of clubs. So basically there's 4 suits the royal flush could be. So that's why there's 4. Is that clear to everyone? That's the easy one. Okay, wait till we see the hard one. Okay, so now we got to say, well, how many poker hands are there? Okay, and this example, by the way, I know this is going to be not easy, but this is much easier than true poker. I cannot get into the true poker because it's way complicated and you would like all be like logging off. It would be so scary. But we can get into this kind of poker, which is this 5-card stud, they call it. And that is how many different poker hands are there? And I want to mention something. What a poker hand means is that you picked 5 cards. And what we're going to look at is the order at which you get your cards. So if you have an ace, king, queen, jack, 10 of spades, or if you have a king, ace, queen, jack, 10 of spades, we're going to call that the same hand. And in poker, you call that the same hand because the order doesn't matter. Okay, so what we want to do is we want to say, if the order doesn't matter, and we have 52 cards, there's 52 cards, and we want to pick 5 of them, how many ways are there of doing it? Okay, and I don't expect any of you to just be able to like figure that out in your head. Instead, what we're going to do is we're going to use the calculator. So here's the calculator. And this is what's called combinations and permutations calculator. One of the things about our calculator is I made sure that I made them in order at which we do things. So we already did Z-score last week. So now we're here on combinations and permutations. So I'm going to click that. It says, what is N? N is the number of cards. So what is N? It's the number of things you can pick from. Yeah, 52. And R will be the number of things that you pick. How many things do we pick? It's 5, because it's a 5-card poker hand. Any questions so far? All right. CNR really means order doesn't matter. PNR means order does matter. C stands for combinations. P stands for permutations. So I'm going to calculate CNR. And there we go. And there's our answer. And if you look, it's a lot. It's 2,598,960. Okay, there's a lot of different 5-card hands. So if I look at the answer, it's that one. You get 4 over 2,598,960, or about 0.0000001539. Okay, really small probability. Any questions on that? Any questions on this example for probability? Okay, by the way, I'm not ever going to require you to know everything about playing cards or anything like that, but I will tell you that if you play in the casino and you're not a full expert in poker, I recommend not playing because you'll lose a lot of money. Okay, it's just a very bad idea. And I'll let you know if you play anything else. Can I go back to the calculator part? Sure. So here's the calculator. N is the kind of the number of things that you're picking from, and R is the number of ways of winning. So this is so N is like not as N we're picking. Sorry, is how many we're picking, not the number of ways of winning. So N is the number we're picking from, and R is how many we're picking. So we're picking from a 52 card hand, and there are 5 things we picked. Does that make sense? I try to make it simple, and you calculate and CNR, which is pretty much always what we're going to be doing if you're doing a picking kind of thing. Okay, So let's go ahead and let you know, by the way, again, poker, don't even think about it unless you are like a full expert in it, or you're going to lose money because there's always a few experts in there that can take all your money. If you play anything else like blackjack, I will tell you that in the long term, you will lose. Okay. And if you don't like it, it's my fault. You know why? Yes? Yeah, you probably won't guess. When I got here, the casinos actually hired me to help them change their rules and make sure everyone loses. And I got paid. And that's when that's when corporations took over the mafia. And the mafia didn't rule; they used to just kill people who were winning. Now, the corporations just make sure no one can win, and no one gets killed. So it's better, I think. So let's go and do another example. All right, suppose we have a 20-question quiz, and each question is multiple choice, and there's four possibilities. There's 4 choices for each question. Okay, and you've all probably taken kind of quizzes like this, right? Where it was multiple choice. And the question is, find the probability of getting them all correct. Okay. So what we're going to do on this one is we're going to say, what's the probability of the first one being correct? Well, if there's 4 choices and you're picking one of the choices, only one is correct. There's one that's correct. There's 4 choices. So 1 out of 4, or 1/4, is the probability of getting that first one correct. Any questions on that so far? Okay. And the second question has nothing to do with the first question. You're still just guessing. And when 2 things have nothing to do with each other, you can actually use what's called the multiplication principle. And that means we can just multiply the probabilities together. So the second one will also be 1/4 because you have one of them will be correct and there's 4 choices. And then you're going to keep going over and over and over again until you get to the 20th one. And that'll also have a probability of 1/4. Anyone lost on that idea? So we're going to have 1/4 times 1/4 times 1/4 times 1/4 times 1/4 times 1/4. And I don't want to say it all day long. I say it 20 times and then I'm done. The way you write that in math is you can write it as 1/4 to the 20th power. Any questions on that? Any questions? And I put that in my calculator and I got something really close to 0. Yeah, you just do it with that. Yeah, you just do 1/4 to the 20th power. I'll tell you the easiest way, the way I like to do it is I'll just go to Google and I'll just type parenthesis 1/4 and the parenthesis. And then I took the little shift 6 is a little caret and that's power. And then I'll go 20. It just tells me. And this is important. I want to show you this. The probability is not 9.09, about. What you always have to do, and this is going to come up a lot, is over on the very far right of the answer, you see this E-13. And that's called scientific notation. What that means is we have to move the decimal to the left 13 places. And once we've moved it the first place, it's on the other side of the 9. The next, we got to put a 0 there. And then a 0, 0, 0. There'll be 12 zeros and then the 9. So be very careful with the calculator because when you have really small numbers, it's almost always going to give you this E thing. And just note, if you're using a smartphone, smartphones tend to have smaller screens. You're going to have to move. You're going to have to kind of move through it to find the end, and you'll see that E-13. If you ever are asked to find a probability and you ever give anything bigger than 1, it's wrong. It almost always means that you didn't read the far right and see that E- something. So that's just a very important little thing to get because a lot of people make that mistake. So don't make that mistake. Probabilities can never be bigger than 1. The mistake is almost always you're not looking far to the right, or you're not scrolling far to the right if you have a smartphone, which has smaller screens. Any questions on that? Okay, so now that we know that, a couple words that are important. In this example, this is called with replacement because you could choose A for the first one, and on the second one, you can choose an A again if you want. And that's with replacement. On the other hand, when we looked at the poker example, when we picked 5 cards, that was without replacement. Because if you know the first one is an ace of spades, the second card I picked cannot be an ace of spades because we're not replacing the first card and putting it back and picking the second. So it's important to know the difference between with replacement and without replacement. When it's with replacement, we get to use this multiplication principle. And that is you just multiply them out. Okay, without replacement, you're going to have to use that given that we did in the last example. Okay, any questions on that? All right, so now the big question, very important. Here's my lottery ticket. Let me bring it real close. You'll notice I bought 2 of them. Cost me $4, by the way. I bought 2 of them. And the question is, what is the probability that I won? Should you go into my office right now with a gun and say, I'm gonna shoot you if you don't give me your ticket? Is it worth it to you guys? Because this is going to be worth, by the way, let me show you something. $835 million if this is a winning ticket. Okay, so should you come in with a gun and grab it from me? It's a lot of money. Okay, well, the idea is let's find out what the probability of this being a winning ticket to see if it's worth it. And by the way, no one will know until tomorrow night because that's when they pick the winning numbers. Okay, that's what because I bought this morning. Okay, I hope it's a winning ticket, but how likely is it to be a winning ticket? Is this a winning lottery ticket? What do you think? Okay, so what we need to do is we need to find the probability to do that. I'm going to go, this is the website, by the way, of California Lottery and Powerball. And if I scroll and I hit how to play, that's important. And let's read it. Step 1 is what we need. And it says using a lottery play slip, which you can find at any lottery retail. And I just went to my nearest lottery place. I walked over and bought the ticket. Pick 5 numbers between 1 and 69 and 1 power number between 1 and 26. Okay. I didn't do quick pick. Okay. But I did let the random number generator pick my numbers, and that way it's completely random. All right, and we want to find out what's the probability that I have a winning ticket. So let's go ahead and do that. What's the probability of a win? So the first thing, as we've seen before, it's a fraction. And with fractions, it's easier to use the equation editor. And then I'm going to go and grab the fraction in Google. That is that one. And how many ways can this be a winning ticket? And when I say win, I'm greedy. For me, I want to win over $800 million. Okay, not some $4 ticket, okay, or $10. I have played the lottery and won like $4 before. But how many ways are the big winner for this to be the big winner? What do you think? This is easy. The denominator is going to be hard, but the numerator is easy. Okay, it's not 1. So what did I tell you? I bought 2 of these, remember? And I bought 2 because I'm doing this for work, and I wanted to make sure that you all understand the numerator is a number of ways of making it win, and I purchased 2 sets of numbers. You see? So there are 2 ways of me winning. Yeah, it's it's not quite how many numbers I chose, it's how many tickets I bought and put it on this thing. That's what it is in this case. So 2 is going to be the numerator. Now the denominator, now we have to go back and remember the rules of the game. And it was, I'm going to pick 5 numbers between 1 and 69. So I'm going to go to the calculator now. And there are 69 numbers between 1 and 69. And I'm picking 5 of them. Order doesn't matter. I'm going to calculate. And I get 11,238,513. Okay, so I'm going to do that. Then I'm going to multiply that by, if you look at the second piece of the lottery is that you also pick a power number between 1 and 26. And by the way, if you look at the rules, you're allowed to have a power number repeat one of the other numbers. Okay, that's allowed. So that means that's a width replacement, it's just multiplication. So then I go ahead and I multiply by the number between 1 and 26, and there's 26 of them. Any questions on that? Okay, so now let's look at that denominator. And that's such a big number, it's hard to read. 292,201,338. So my probability that this is a winning ticket is 2 over 292,201,338. Okay, so what do you think? Think I'll win? Think I got a winning ticket? Yeah, probably not very likely to be the big winner. Okay, is it possible? Yeah, it's possible, but I strongly recommend you don't come into my office with a gun and steal my ticket, because you will have a 2 in around 292 million chances that this is the big super winner. And I don't think that's enough for you to want to like come in with a gun. Not a good idea. Any questions on this probability example? All right, so now let's continue on. That was the probability of winning. Okay, so here's another example. Suppose that 20% of all students taking stats at Lake Tahoe Community College are African American. By the way, I just want to give you a heads up. I made this number. When I say made up this number, I say suppose that. Don't quote me on these numbers. You could probably look it up and find out, but I just want to make the numbers easy. So suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans. And 40% of all stat students at LTCC are non-STEM majors. Okay, I also made that up too. If 22% of LTCC stat students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. Okay, so do you remember my warning at the beginning about chapter 3? You remember what I warned you about? It's hard. Okay. And all of a sudden, this is hard. But I want to let you know this paragraph This is more useful than the other stuff. Okay, I mean, unless you're a gambler, but this is really how you use probability most of the time, is you want to look at, based on some information that you're able to find out, let's see if we can figure out some more information. And that's a very important life skill. Hopefully you all agree with that. So this is an example of one you might need to do that with. So here's my suggestion. When you have a question that you have to do in probability that's given as a kind of long paragraph, read the question. Don't get scared and run away, but instead go back and read it slowly. And every time you see a phrase and or particularly a number, take that phrase and or particularly a number and see if we can write that down using symbols. Okay, because if you read this whole paragraph, it could be really scary. So let's go ahead and go back and read it one piece at a time. So suppose 20% of all students taking stats at LTCC are African American. Okay, so our population in this thing is just stats students at LTCC. 20% are African American. So I can write that in symbols, probability, or P, parenthesis A for African American, and the parenthesis is equal to, and it's very important you know how to take a decimal, a percent, and turn it into a decimal. So 20%, if you move the decimal over 2 places, you get 0.2. Any questions on taking that first phrase and putting it into a probability equation? Any questions? Because it's a very, very important skill to have in this class. Okay, if you try to do the whole paragraph, it's too hard. One phrase at a time. All right, next. And 40% of all stats students at LTCC are non-STEM majors. Okay, so probability, that's a probability. So P, and I'm going to use N to represent non-STEM. I tend to like to use the first letter of kind of the big thing to put into those parentheses. You could use a word if you want, just less writing to use the first letter. If there's 2 words that have the same first letter, you might want to use a couple letters, just let you know that. Okay, or get creative and use a synonym for one of the words. Okay, but this example, I made sure that there aren't any of that issues. So P of parenthesis N equals 0.4, and that's because 40% as a decimal is 0.4. Any questions on taking this second phrase and turning it into a probability statement in symbols? Any questions? Okay, next. If 22% of LTC stat students, non-STEM majors, are African American. All right, so now we got to think about this. What we're doing is we're saying we're going to take these LTCC stat students, but we're only going to look at the non-STEM majors. Okay, of them, 20% are African Americans. So we're told, or we're given, that the student is non-STEM, and we're saying the probability, given they're non-STEM, of being African American is 22%. So the way we write that down is P for probability, parenthesis. We want the probability of being an African American, that's A, given we use that little vertical line segment. Non-STEM, that's N. And the parenthesis, and that probability was 22%, and you write that as a decimal as 0.22. Okay, that was a little bit harder, but not impossible. So any questions at all on that phrase? Any questions? Okay. Now let's look at the next phrase. And you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. So now what we're doing is now we're going to pick a student and we're told the person is African American. We want to find the probability that the student is non-STEM. So we want the probability of non-STEMs, that's P parentheses N, and we're given, that's a little given, that the person is African American. There's the A. So it's the probability of N given A. This is what we're asked to find because it says what or find the probability. When you're asked to find something, I like to write a question mark. So that's equal, I don't know, question mark. Any questions at all about taking this paragraph and turning it into symbols, symbolic equations? That is literally the hardest part. Yeah, question?
So it says P and then A given N is that. So P and then N given A. The second one and the third and the fourth one are different just because they're in a different order.
Yeah, so the way you
Okay.
read the first one in words, that's a really good question because you're just at the beginning of this, is you say, what is the probability of being African American if you're told the person is non-STEM? The second one is, what is the probability that a person is non-STEM if you're told the person is African American? Do you hear the difference between those two?
Yeah, and so I'm sure you're about to get to this. Those are different equations because that first one would have just been probability of A multiplied by probability of B or to N to get to that 0.22.
Okay. So
right?
here, so a given. So what we're going to do, and this is what's right below that. Here's a key formula. Do you remember this little formula? We now have it. That happened when I did the probability that you get two, I think it was kings. Do you remember that example?
Yeah.
So this is similar. So this is the formula we use for that. And and so I'm rewriting that formula. Probability of A and B is equal to the probability of A times the probability of B given A. Does that make sense?
Yeah.
So from that, we can, and by the way, you can also say the probability of A and B is equal to the probability of B times the probability of A given B, because A and B is exactly the same thing as saying B and A. Do you agree? So being a king and a heart is the same thing as being a heart and a king. Do you agree? Or being African American and a non-STEM major is the same as being a non-STEM major and being an African American. So with the word and, it goes either way. With the word given, it does not go either way. And that's really important to know. All right. So what I can do is I can take this statement right here, and I can do a little bit of basic algebra, and I can divide both sides by the probability of B, P of B. And when I do that, I get probability of A given B by itself because I'm basically getting rid of the probability of B. And I can write the probability of A given B is equal to the probability of A and B divided by the probability of B, because I'm dividing by the probability of B on this with this equation. Any questions on this formula? This is a very important formula. Any questions? Okay, so we know the probability of A and B equals the probability of B times the probability of A given B. So now we can write the probability of A and N using A for African Americans, A for non-STEM, will be the probability of non-STEM. Non-STEM probability was 0.4 times the probability of African American given non-stem. And that is 0.22. So probability of A and N is equal to 0.4 times 0.22. Now I can use this formula and say the probability of N given A is equal to the probability of A and N divided, notice this formula says whatever's the second one goes in the denominator. So the second one's an A divided by the probability of A. Probability of A was 0.2. So that is going to be 0.4 times 0.22 divided by 0.2. Okay, so are you starting to believe me about my warning that this actually has math? Whereas last week hardly looked like math at all. But this week has some math in it. And that is, we're going to have these equations and we have to work with them. Any questions at all on this probability question? Okay, and by the way, if you want, you can work this out. You can pop into a calculator. And what do you get? Maybe I'll just do it in my head. I get 0.044. You can stick in a calculator instead of you, or you can use your human brain calculator too if you want, but you're always welcome to use a calculator. Any questions at all on this example? Okay. So again, this is an important formula. Probability of A given B equals probability of A and B divided by probability of B. Also, probability of A and B equals the probability of A given B times the probability of B. Any questions at all on that? Okay, so let's do the next example. Let me make this a little bigger so you can see it. Suppose you roll 2 6-sided dice. So again, I live in a gambling town, and anyone know the main gambling that people play with dice in gambling places? Tahoe particularly? Yeah, craps. Okay, so I'm not going to go into all the details of craps, but I actually used to teach a class on the probabilities of gambling, but not now. But we'll do this example. So 2 6-sided dice, find the probability of the sum of the dice is a 5. Like a 4 and a 1 makes it a 5. Do you see? All right. So how many ways are there of rolling dice so the sum is a 5? So I think the easiest way of doing that is just listing them. You can roll a 1 and a 4, a 2 and a 3, a 3 and a 2, a 4 and a 1, and that's it. Do you agree? So there's 4 ways of rolling a 5. How many 6-sided dice? How many sums are there? Or how many rolls are there of the 2 dice? Okay, and the way I did it, because I said 1 and a 4 and a 4 and a 1, I counted those differently. So what we can do is we can say, how many ways are there for the first dice? That should be easy. There's 6. How many ways are there for the second die? Yeah, 6 again. So how many different rolls are there? See if you can come up with the right math for that. If you can do it in your head. Yeah, there's 36. Because 6 times 6. There's 6 1s, 6 2s, 6 3s, 6 4s, 6 5s, and 6 6s. Okay, you can kind of look at it that way. 6 where the first is a 1, 6 where the first is a 2. That's what I meant, etc. So the probability of sum of the 5 is 4 out of 36. Any questions on that? Easy enough? All right. Let me do an example with what's called a contingency table. And these happen a lot. All right. So let's suppose a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. And this is a table of the answers. So here's what we have. We have, if you don't know what these are, this is Cal State University. So a lot of students transfer to Cal State universities. This is University of California or UC campuses. This is, if you're not from our area, you may not know, but it's University of Nevada, Reno. That is actually it's our closest university, but it's not in our state, so not quite as many. And then other universities. And the places where they're going to live are an apartment. They can live with their parents or some other living situation. Okay, maybe they're in a dorm, or maybe they're homeless for all we know. We don't know, but there's others they can live in. So first thing I wanted to tell you how you read this table, because that's very important. You can have lots of questions about these kind of things. So let's look at this number 7. That's my favorite number. Okay, my lucky number. And I remember it was someone else's who put it in the 2 truths and 1 untruth. But my favorite 7. That 7 means of the students that were asked, 7 of them are transferring to University of Nevada, Reno, and will live with their parents. Do you see how that 7 can be read? If you look at this 33 will be living in an apartment and transferring to a UC campus. So it's very important you know how to read these. Okay, this is very typical of studies, is they'll ask a couple questions and they'll write this in a contingency table. So here's a question. Find the probability that a randomly selected student will go to a UC campus or will live in an apartment. Okay, and just to save time, note there were 246 students. And if I didn't tell you that, you could just add 43 plus 33 plus 19 plus 22 plus 33 plus 8 plus 7 plus 15 plus 20 plus 19 plus 15 plus 11. It'll take some time, but you get a calculator and you get 246. Okay. So we want the probability the randomly selected student will go to UC campus or live in an apartment. So here's a very important formula, and that is the probability of A or B. So is that 2 different answers? No, there's only one answer to this. Okay, there's a probability that one of these 2 things or both will happen. Okay, so or means, so let's put it this way. Let me give you an example. Let's suppose you own a bar. Okay, you own a bar, a drinking bar. Okay, and to get into the drinking bar, we're gonna say there's a $5 fee just to walk in. Got it? Okay, it's a special bar, and people really want to go. So, sorry, let's not go for $5 fee. Let's say you own a bar, right? Instead of having a fee, let's do this example. You own a bar, but also a restaurant that's connected to the bar. Okay. And you want to find out who's going to come into your place. Well, who's going to come in? Well, either people who enjoy going to bars or people who want to go to your restaurant and eat. Do you see that? And you want to find out the probability, if you randomly pick someone, what's the probability that they're going to come and give you money, right? Come to your bar or go to your restaurant. Okay, and by the way, if they do both, then there's still a person that's going to come in. Do you see? Yeah, it's combining the 2, and that's what or means. Okay, so it could fit both, it could fit only one, but it won't fit neither to be accepted in the numerator. Do you see that? And that's how you read that. Okay, and that word or is very important. Okay, so probability of A or B, this is a very important formula, is the probability of A plus the probability of B minus the probability of A and B. Okay, and that is a formula. I'm not going to prove it, but I could if you wanted. It's kind of my office hours, but or you just trust me. That's your choice. Okay, so that's an important formula. So now what we can do is we can say what's the probability? We want to find out the probability of going to a UC campus or living in an apartment. So P of UC or A. So I use the formula. That's P of UC plus P of A minus P of UC and A. Any questions on that? And the way we do that is we're going to do those one at a time. Let's first find P of UC. And to do that, we want to say, how many UC students are there? Well, there's a 33 plus the 8 plus the 19. And that's the numerator. How many students were there? That was 246. So that numerator is 33. I mean, the fraction, that probability of UC is 33 plus 8 plus 19 divided by 246. Okay, probability of an apartment is 43 plus 33 plus 19 plus 22. And still divided by 246, because it's still all the people who are transferred from LTCC. And then we're going to go minus probability of UC and A, okay, or and apartment. And those are these 33 students, because those are the ones that are both going to live in an apartment and transfer to UC campus. So that's 33 over 246. Any questions on that? Okay, hopefully it's okay with you. To save you time, I'm going to assume you know how to put that in a calculator. Stick it in a calculator and you'll get a number. Sound good? And when you're doing it on the assignments, make sure you carry the number of decimal places that the assignment asks for. So if it says 4 decimal places, give 4 decimal places. Okay. All right, now a couple definitions. Here's the first one. 2 events, A and B, are mutually exclusive if the probability of A and B equals 0. Okay, so here's the question. Are transferring to a CSU campus and living with parents, are those 2 things mutually exclusive? So to find that out, let's find out the probability of CSU and living with parents. Well, that numerator is 34. The denominator is 246. I don't need a calculator to know that when I divide those, I do not get 0. Okay, you can stick it in a calculator, you won't get 0, but do you agree that that's not 0? Okay, so in particular, CSU and living with parents are not mutually exclusive. Okay, let me give you an example of being mutually exclusive. Let's say we want to let's say A be the probability that a person was born in California. Got it? And let's say B is the probability that a person was born in China. Are A and B mutually exclusive? What do you think? Okay, well, let's think about it. What is the probability of being born in California and being born in China? Yeah, it's 0. Okay, you can't be born in California and China. That cannot happen. Okay, it's not possible. Hopefully you know that it's not possible, right? I was born in California. I was not born in China, by the way, but I was born in California. Okay, you cannot be born in both places. You can't have that and occur. Do you see that? So when you're looking at mutually exclusive, kind of the idea is if both cannot both occur, then they're mutually exclusive. Because the probability of 0 is if both can't occur. Any questions on mutually exclusive? It's usually not that hard, but I figured I should explain it anyway. Okay, the next one's a bit harder, and that is two events A and B are called independent. If any of the three equations are true, the first, probability of A and B equals the probability of A times the probability of B. The second is the probability of A given B is equal to the probability of A. And the third is the probability of B given A is equal to the probability of B. Okay, it turns out if one of them is true, then the other two are both true. If one of them is false, then the other two are both false. That's one of those I could prove for you, but I don't want to waste your time, but using some equations, I could do that. Welcome to come to office hours if you want to see the proof, but you're not responsible. But hopefully you can trust me. So if you want to find out if two events are independent, and by the way, the opposite of independent, any guess? If they're not independent, what do you usually call it? It's words, you probably know it's English. Yeah, dependent. Those are the two things that can happen, independent and dependent. Okay, so if they're not independent, we say they're dependent. So here's one of the challenges. If you want to find out if they're independent or dependent, there are three equations you can look at. Which should you use? Any guesses? You'll laugh when I tell you this. It's the obvious thing. Not necessarily any. All right, let me tell you. You should choose whichever's easiest. Often one of them is really easy and the other two are really hard. Don't torture yourself. Choose the easy of the three. Okay, and it really depends on the situation. Okay, different situations will have easier choices. Does that make sense? Okay, so choose the easiest of the three. So are living in an apartment and transferring to UNR independent? So in this case, it turns out that the first is the hardest of the three because the first has three probabilities to calculate. Do you see that? I see three P's. Do you see three P's? The second and the third only have two. So we could choose the second and the third to be easier so we don't have to torture ourselves. Sound good? So it turns out with this example, the second and third are just as easy as each other. I'm just going to choose, let's find the probability of an apartment given that they are a UNR, they're transferring UNR. So if I go up here, so if I'm given they're transferring UNR, these are the groups, these are the people that are transferring UNR. Okay, 19 of them are going to live in an apartment, 7 of them are going to live with parents, 15 will live in other. The total amount of UNR transfers, 19 plus 7 plus 15. 19 of them are going to be in an apartment. So the probability of an apartment given UNR is 19 over the sum of those three. By the way, 19 plus 7 is 26. 26 plus 15 is 41. Always a lot easier calculator if you don't want to like do what I'm doing, which is do it in my head. And I recommend using calculator on a test so you don't make mistakes. So you get 19 over 41. I put that in a calculator and I got 0.463 and a bunch more decimal places. Probability of living in an apartment. Then you say, well, how many are living in an apartment? 43 plus 33 plus 19 plus 22. That was 117 when I did that one in my head. And then there are 246 living in an apartment. And if I divide, I get 0.475. Okay, they're not equal. Do you agree? 0.463 and 0.475 are not equal. So if they're not equal, then we say living in an apartment and transferring in UNR are dependent events. Any questions on that? Okay, I want to look at this in kind of a more idea way instead of equation way also. So probability, if you're told someone's transferring to UNR and you want to find out what's the probability they're going to live in an apartment, that's not the same as if you're not told and you want to find out the probability they're living in an apartment. So if you're given the information that they're going to transfer to UNR, that changes the probability they're going to live in an apartment. Does that make sense? It's kind of an idea. There's a lot of things you can think about. Do you think they're independent or not based on more of the feel? So for example, if let's look at one of my favorites is let's suppose, let's let event A be the event that it's trafficy in our Highway 50 in Lake Tahoe. And let's let event B be the event that the soccer team in New Zealand high school won the last time they played. Do you think those are dependent or independent? Yeah, I would certainly guess those are independent. If I knew that soccer team in New Zealand won the last time they played, that's not going to help me at all on deciding whether there's going to be traffic in Tahoe. Do you see that? Okay, so often it means they have nothing to do with each other. That's common. Do you see? If they completely have nothing to do with each other, they'll be independent. That make sense? Mutually exclusive and independent are very different. Look at these equations here. And then if you look at mutually exclusive, that's P of A and B equals 0. They're totally different things. So, and even in the ideas, A and B means they can't both happen. Whereas here, it means if one happens, that helps you understand if the second happens. They're very different. Yeah, they're very different ideas. Okay, does that make sense? Okay, what if, let's do another one just as ideas. Let's suppose A is the event that somebody has at least a bachelor's degree. And let's say B is the event that somebody makes at least $100,000 a year. Are they independent? What do you think? So A means they, again, have a bachelor's degree at least, and B means that they make at least $100,000 a year in their job. Independent or dependent? What's your guess? Okay, let's think about that. They can't be both independent or dependent. That can't be true. You can't have the equation be true and not be true. That can't happen. Yeah, those are going to be dependent. Okay, because if you know somebody makes 100,000, more than 100,000 a year, there's a higher chance they have a bachelor's degree. Do you see that? People who make a lot of money tend to have at least a bachelor's degree. If you're not educated, there's a much higher chance that you don't make a lot of money. Do you see that? Hopefully you know that. That's, for some of you, that might be why you're in college right now, because you want to make money when you get out. Do you see how that works? Knowledge of one helps you understand the other. Are they mutually exclusive? Right. Some people make a lot of money, but don't have a bachelor's degree. But that's not saying that the probability is the same. If you have a bachelor's degree, your probability of making higher money is more than if you don't have a bachelor's degree. Do you see that? It changes the probability. Are they mutually exclusive? Right? They're not mutually exclusive because you can have a bachelor's degree and make over 100,000 a year. Do you see? A lot of people do that. Any questions on that? Okay, so that's an example. Now, let me give you something that is very important, and that is a secret word. The secret word for this webinar is fraction. And that I always try and do a useful word, because if you remember what probabilities are, you can think of them as a fraction, where the numerator is the number of ways of making that thing happen, and the denominator is the number of different things that can happen. So that's why the secret word for this week is fraction. So hopefully you all have that. Okay, because then we're going to move on. By the way, we're not done. We still have more time and more stuff to do. But we're done with the talking about chapter 3. Any questions on the secret word before I erase it for good? Okay, so now let us move on to our syllabus and something very important, and that is project 1. And I want to let you know you have until October 22nd, almost a month from now to do the project. Okay, so here's one thing that I strongly recommend you don't do, and that is procrastinate. Procrastination is a very bad habit. Do not wait until October 21st to start working on your project. It's a very bad idea. Okay. In fact, you should have already been working on it kind of last week, and that was finding partners. Okay. So that's one thing, is you must have partners. And I want to remind you, and I showed you this during the orientation webinar, but I want to remind you again. Where was that? Not too far. There it is. And that is students are to work in pairs or trios. So I recommend 3. One biggie is it's less work because you only do 1/3 of the work. And the other biggie is that if someone drops out, you're not screwed. Okay. I did notice that somebody said, and I never mentioned names in these recorded webinars, but someone did say they want to work in as only a pair and not a trio. Bad idea. One thing is, if your partner drops out, you're screwed. So much better if you can to work in a trio. And, if you want to just like do a lot of work, you can still do a lot of work. Okay. You can, look at what the others have done and help them improve and learn all the stuff. And if you want to do a lot, you can still do a lot. That's allowed, by the way. Okay. But I do recommend that you break it up into pieces, but then you get together and, all of you do the work on making sure it's all good. Does that make sense? Okay. And 25% penalty is a disaster. You do not want that. So you do not work alone. Don't even think about it. That's horrible. Okay. In terms of the timeline, okay, I want to remind you that I'm going to look at a rough draft before it's due if it's sent by Thursday at a.m., but I recommend earlier so that you have, one thing is it might take me a while to read it. These projects are long, and there could be 15 of them. Okay, or sorry, it could be 30 of them. That's the max, but my guess is it won't, because you'll be in trios. Okay, and I don't want to, speak negatively, but there's always a few people that drop. Okay, I don't like it, but some people do drop the class. Okay, family stuff happens or whatever happens. But either way, there's a lot for me to read, and if all of you submitted it, at 7:59 a.m., then the one that did it last is, boy, you're gonna have to wait a long time. So just note, Because if they're, even if they're only 10 pages each, that's hundreds and hundreds of pages. And I can't do that in a couple hours. Just let you know that. I read, but not that fast. And then I got to type out lots of comments. Okay. So that's a big note. And I do want to remind you that that we do have an embedded tutor that will help you also. Okay, and is he still here? Let's see. Look at the list. May not be here right now, but we do have our embedded tutor, and he can help out. And other tutors can help too. So just a note, get help. Don't this is not one that you should do without, kind of working. Don't just ask AI to do it. I'll know, and it's going to be bad for you. Okay, because all the things I ask you to do, AI won't do it exactly as I ask you, and I want you to do it that way. And I'll zap you if you just ask ChatGPT to do it for you. You'll get a very low score because I will be very mean on the grading. I just want to give you a big warning about that. And that's true of the exams too, is that I can tell when people are using it. I noticed some people used it on the discussion assignments. Bad idea. I tend to grade harder on that, and I'm really mean on if you just use AI to write the paper for you or to do your exam for you. It's not going to be good for you. Just big heads up. It'll be ugly. So you do need to work together, and you should do the work and not let AI do it. And I can tell, by the way. I am a computer programmer, and I have programmed AI. So I know the back end of it too, not just the front end. So just big warning. Okay, so if you click on this project 1, these are the requirements. So I'm going to go through these piece at a time. First thing, think of a quantitative investigation that someone might contract out to have done. Who remembers what quantitative means? We talked about this last week. Okay, and this project is mostly on chapters 1 and 2. Yeah, it means that the answer to the survey question, and you're going to be asking survey questions, must be a number. And just a note, and I'll get in this a little bit, you want it to be at least 2 digits. Okay, do you remember last week I mentioned why 2 digits is good for something? There was a detail that happened last week. Remember? Open it up. You may not remember. Stem and leaf plots. 1 digit doesn't work for stem and leaf plots. So make sure that, answers could be 2 digits. You could do more than 2 digits, but at least 2 digits. Okay. All right. A couple things. Someone might contract out to have done. Okay. If no one would ever be interested in your results, then it doesn't make a good project. Okay. It doesn't mean that you actually have to find someone to pay you, but it means that at least theoretically you could. And you're going to have to, in your paper, pretty much you are writing it to the person that would be contracting you out to have it done. Not to me, to your person, your client is who I'm going to call it. Okay. That is who you're writing it for. Okay. Then you're going to go and perform this investigation. Okay. And you're going to produce a report as though you were handing the report to the person paying for your services. And by the way, it's a might, and I do not expect you to necessarily be able to contact get that person to pay. It could be, say, I don't know, President Biden might be the person who might be interested in your results. Does that make sense? But I do not require you to talk to President Biden. It'd be cool if you could, but finding the president, no matter who the president happens to be, is not easy to get them to talk to you. But you can imagine it. Okay, it could be President Biden. It could be, I don't know, it could be the president of our college. It could be the owner of a restaurant. There's lots of different, people that might be interested in understanding some statistics. Okay. So the purpose of the report is to make recommendations based on your finding to make so be sure to make the recommendations throughout the entire paper. That's the number one mistake that people make in their draft. Just let you know that. And that is what they do is they send their draft, they find the statistics, and they might talk about standard deviation, they might talk about the histogram, but they don't make recommendations on what the decision that the client should make after seeing that statistic or that chart for every statistic and every chart. Okay, so that's the important thing. That's what this paper is all about. Include a statement on who hired you and why they hired you. Okay, in theory, by the way, they're hiring you. Okay, here's some things you have to have. Okay, you have to talk about the sampling technique. I actually mentioned this last time. And the choices are simple random sampling, stratified sampling, or cluster sampling. Those are the three possibilities. Just a note, I put links to stratified sampling and cluster sampling because those are things that people forget what they're all about. And those links will remind you what they're all about. I didn't put a link to simple random sampling. Do you remember what I said about simple random sampling? The biggest issue? It's not exactly the exact opposite of lazy. It's almost always impossible, and it's almost always the hardest thing. So if you think you can simple random sample, people in California think again, it can't happen. So I would say not even 1% of all projects can use simple random sampling. Almost all of them either use stratified or cluster sampling. And there's definitely a mix between the two. I don't know if it's 50-50, but it's not far from 50-50. Okay, very, very few use simple random sampling because it's almost impossible. Good luck. Okay. All right, you should talk about any bias that might have occurred in your sampling technique. So note that bias involves a misrepresentation of the population. So the sample data does not represent the population data. So when you're discussing your bias, will the mean be lower because of the bias, or will the mean be higher because of the bias? If you don't talk about that, that's not good. That's a very common error I find. And I have to let people know, hey, this needs to be fixed when you send your draft. And if you don't send the draft, then I'll let you know when I give you your grade, and I'll take off points, by the way. Just let you know that. That's why it's really good to send the draft. So I can let you know of all the mistakes so you can fix them and get the A. I want you to all get A's. But again, good luck it's almost impossible to get an A if you don't give me a draft, because you're not going to very few people know all the different things and, pay attention to every little item. Okay. Okay. The sample size must be bigger than 30. What's the biggest number it could be? What's the smallest number it could be for a sample size for the number of people you survey? Nope, you can't survey 30. 30 is not bigger than 30. What's the smallest number you can do? 31. Okay. 31 is the smallest I will accept. Okay. And I don't give more points if you do 500 than if you do 31, by the way. Okay. You can do 32, 33, but don't waste your time and do hundreds. Okay. Better. There's only one reason actually for this project you would do hundreds. And I've had this happen. Anyone know? There's actually a good reason. And I've had this happen, but it probably won't happen to most of you, by the way. Anyone know? Okay, let me tell you, because you're doing it for your job and your boss needs more. Okay, it doesn't happen too often, but every so often people need it for their work. And I get that sometimes. It's really cool, I think. So it does happen. But never 30 or fewer. 31 is the smallest. You won't understand why it has to be bigger than 30 until we get to chapter 5, I believe. Let's see. No, sorry, chapter 7. Chapter 7. In chapter 7, we're going to have a reason for it. But now you just got to trust it, that that's the important number. Okay, here's, yeah, you have to find real people to survey, exactly. Yeah, fake people aren't allowed. And you could do it by talking to people. You could do it online. Be careful, you will almost certainly have voluntary response bias if you do it online, but as long as you do it using, like, say, stratified sampling or possibly cluster sampling, then you can do an online survey with people. But just note that if you do it online, you're gonna have a very small response rate. So you're probably gonna have to, like, make sure there's a big group that can be answering. Otherwise, you won't get 31. Just a note, just a warning. Yeah, you can make the part up, but it has to be reasonable. So if you're making it up, make sure it's actually someone who would hire you. At least in your mind, that they would benefit from it. Do you see that? Yeah. Yeah. And so, like I said, it could be Biden, even though Biden's not hiring you, because getting the president to hire you that's hard. Okay. There's a lot of people that could maybe hire you, but not necessarily. Okay. All right. Any questions so far? All right. Let's look at some more. So you must include all the relevant charts. And here's the 3 that must be included. And that is histogram, stem and leaf, and the box and whiskers plot. Now, you may or may not remember, but those are the 3 examples I gave last week. There's a reason. I did it so that you're ready for the project. Okay. You can include others, like a pie chart or a line plot, but those aren't necessary. But these 3 are necessary: the histogram, stem and leaf, and box and whiskers. Okay. You must be using a spreadsheet program to do your work. The reason I make you do that is that there are some universities that require it for transfer. So if you don't, then this class may not transfer. But if I require it, then pretty much every university accepts this as their general education statistics transfer. So that's the reason. Okay. So it has to be done. Okay. So that's really important. Just a note, just like I said with all the statistics, when you do the histogram, talk about, after looking at just the histogram, what decisions might the client make? Okay, and just a reminder, the histogram is really good for showing the shape of the data. That's really good for that. After looking at the stem and leaf, what decisions might the client make? Okay, stem and leaf is really good because you can look at the shape of the data and you can also see individual data values. Okay, one problem with the stem and leaf in terms of the shape is stem and leaf has to be by like tens or hundreds, whereas histogram, you can choose whatever, you can do it 0 to 5, 6 to 10, et cetera, et cetera. You can choose interesting groupings. Okay. And then box and whiskers are really good because you get that middle 50%, which is nice. That's the box. So make sure for each of the plots, talk about what decisions your client would make. Any questions on that? All right. Just a note, because a lot of people make this mistake, and this is a disaster. It's not a comparison study. So how many survey questions should you have? 1, exactly, 1. It's not a comparison study. Okay. The only reason why you could ask something else, but not as a comparison study, is if you're doing stratified sampling, you might do it by the strata. But in your paper, let's say you stratified by race. You're not comparing, say, Caucasians to Hispanics. Don't do that. Okay. You're only using race so that you make sure that you don't have any racial bias in your study. You're not comparing one race to another if you're doing that. Does that make sense? Okay. So your data will be one single column. Okay. I'm putting this stuff in because those are common mistakes people make. There will be a single sample mean. If you have 2 sample means, you screwed up. That means you're trying to compare something. There should be a single standard deviation There's a single histogram. There, you will not have two of any of those things. Do you see that? I don't even remember a quarter at which I taught this class and someone didn't make this mistake on comparison. So don't make that mistake, please. Okay. Any questions on that? Okay, just a note, and let's do it this way, I think is easier. I go up here and I go to the syllabus. Then you'll see, actually, if I go to calculate is even better. If I go to the calculator, which was somewhere in here. No, I had it. Where was it? Oh, I think it's in the project. Sorry about that. I was in the wrong spot. If I go to project spreadsheet resources, you go to the Google Sheets statistics package written by Larry Green. Then you go, this is very important. It says, first time you use this, you will need to go to the link right here. You click that link. Then you wait a little bit. This will send you statistics by Larry Green. The very first time you do it, you have to click File, make a copy, and give it a name. Okay. Don't worry about this warning. I will not give you, notice there's no warning. I don't give you any kind of bug. I'm not there's no problem with this. And you hit make a copy. Okay. I'm not going to, but that's what you have to do that so that you can put in data. Otherwise you cannot put in data. Okay. Then the first thing you're going to do is you're going to highlight the numbers that are here, hit your backspace, and that lets you start over. Then you can put your data in, and that might be 5, 65, 75, 22, 33, 38, just making some numbers up, etc. Any questions on that? And then you have all the things you need. Notice it gives you the minimum, the mean, the variance we don't really do much with, the sample standard deviation, very important, the median, the maximum, the third quartile, the sample size. SNL, okay, so what it says is 1, that is if you have a 2-digit number, then 1. Okay, if you had a 3-digit number and you can do it by hundredth, make that a 2. And I can help you on any of this stuff, just let you know that. Q1 is the first quartile. Don't worry about this stuff. This comes up after the project. Don't include any of this stuff. There is a way to do a z-score. You type in the x value. If you do, I don't know, 33, hit enter. That'll give you the z-score for what you're interested in. Remember, you're going to want z-scores, for example, to find out if you have any outliers. So if I take the minimum, which was 5, and hit enter, I get negative 1.3. It's not an outlier because that's less than, that is in between -2 and 1. Do you remember that? Etc., etc. Okay. Most of the stuff you don't need. IQR, we talked about that. The mode, in this case, there weren't any two of the same. Maybe I'll make one. How about 38? How about 75? There we go. Then there'll be a mode. Okay. This stuff, don't worry about. None of this bottom stuff, don't worry about those at all.
I have a quick question.
Yeah.
So you said one column of data. So you're referring to that A column, and that would be our one column of data.
Yeah.
So like, for instance, if I did a study of like, oh, okay, I'm going to ask a bunch of students, obviously not just a bunch, but how many times a day they log into Canvas. And so then those would be the values each there. So like 5 of them did 1 to 3 times, like that. I don't know if I'm making
Well, no, you wouldn't say 5 of them did 1 to
say.
3 times. You'd say, okay, the first person you asked logged in 8 times. The second person you asked logged in 22 times. The third person you asked logged in 4 times. Do you see?
So the A is the group, and then each number is each person I ask, and then I put the value in there.
Yeah. A is just
Okay.
where you put the values.
Oh, and then okay, I see. Sorry, I'm a little bit sick. I'm trying. Thank you so much.
Yeah, good questions. It's very important to ask questions. That's the whole point of these webinars. Okay. All right. So let's continue on. We're almost done. If I go back to this, and I go back to the project. Okay, so you should interpret the charts. I talked about that. You make sure you talk about each of the important statistics and interpret all of those. Just to note, the standard deviation, you must have a full paragraph that goes through standard deviation stuff. That could include the empirical rule or Chebyshev. Okay. If you have a slightly normal distribution, look at your histogram, then you can use the empirical rule. If it's, say, skewed left or skewed right or bimodal, then don't. Then you have to use Chebyshev's. Don't use both, okay? Because empirical rule is better if you can, but if you can't, use Chebyshev's. Okay, talk about what decisions or how those will help the client. Make sure you talk about how you use a Z-score for your study. That could be to find out if you have outliers. It could also be if there's like a very important number. Like, for example, if your survey question was how many hours of sleep do you get? Well, 8 hours is the recommended amount. So find the Z-score for 8 and interpret that. Talk about how your client would use that kind of thing. You should just note this is a paper. So it should be written in essay form. Essay should have an introduction, a body, and a conclusion. So make sure that you have that. Make sure, so you're in conclusion, you talk about the highlights, the most important stuff that happened, and the main takeaways for your client. Okay, that's the big stuff. I'm not going to read through every little bit of it. Just something really important. Do not ever ask children that are under 18 unless they're at your college. Then their parents actually signed their rights away. I don't know if you know that, but they did. But do not go to an elementary school and ask kids, or a high school and ask kids the survey question. You are not allowed to go and ask children because you could get sued. And I could get sued, but now I can't because it's on recording that I told you you're not allowed to. You don't want to get sued, trust me. So children are not allowed to be part of the participants of your study. Now, you can ask adults about their children, but you can't ask children. Does that make sense? Okay, very important. Any questions at all? Do you need to keep track of how many people we ask? Okay, so here's the thing. That's just going to be done for you because you're going to have a list of all the answers, each individual answer that was given, probably on a piece of paper. And then you're going to type that into the spreadsheet. Do you see? If someone doesn't answer, then they didn't answer. But what you should do, if people aren't answering, then in your bias, talk about voluntary response bias. Do you see? Yeah, so that's the important thing. So then you talk about voluntary response bias. Say, hey, I had people, you don't have to say how many people didn't answer, but you say some people wouldn't answer. So we have voluntary response bias. And then because of that, I would probably think that the mean is lower, or I would probably think the mean is higher, and here's why, depending on what your study's about. Any questions on that? Good questions. Okay, I think I am going to call it, this is longer than we usually go for a webinar. So I'm going to stop the recording. And I hope this worked, because if it didn't, I'm screwed. But I'm going to hit stop the recording. I'm doing it a little different way than normal that you don't even notice.